Hello, I am Dr. Sudha from Government Science College, Autonomous, Bengaluru. In this session, let us discuss about the differential equations which are reducible to exact differential equations. In the previous session, we had discussed about differential equations wherein we found integrating factor by inspection. An integrating factor, we know that it is a factor suitable for a differential equation which is not exact, can be made exact by multiplying by it. These are the rules for finding integrating factors of the differential equation of the form mdx plus ndy equal to 0. In the previous session, as I told you, we discussed about integrating factor which was found by inspection. In this session, let us find an integrating factor of a homogeneous differential equation. We also have types of the differential equations for which integrating factor can be found out are of the form f1 of x comma y into y dx plus f2 of x comma y into x dy equal to 0. And for differential equations, mdx plus ndy equal to 0, other than the previous three types which we discussed, and also equation of the type x to the power of a into y to the power of b into my dx plus nx dy plus x to the power of a dash into y to the power of b dash m dash y dx plus n dash x dy equal to 0. In this session, let us discuss about the integrating factor of a homogeneous differential equation. To begin with, let us see what is a homogeneous equation. A differential equation of the form f of x comma y into dx plus g of x comma y into dy equal to 0, where both f of x comma y and g of x comma y are homogeneous functions of the same degree in x and y is called a homogeneous differential equation. So now let us find the integrating factor of a homogeneous differential equation. If mdx plus ndy equal to 0 is a homogeneous differential equation in x and y, then 1 over mx plus ny is an integrating factor provided mx plus ny is not equal to 0. So first we need to check whether mx plus ny is 0 or not. If it is not equal to 0, then 1 over mx plus ny will be the integrating factor, and one has to multiply the given equation mdx plus ndy equal to 0 by 1 over mx plus ny, which makes the given differential equation an exact differential equation, and we all know how to solve an exact differential equation. So let us discuss some examples. Solve x square y minus 2xy square into dx minus of x cube minus 3x square y into dy equal to 0. So the solution is as follows. So let us consider the given differential equation. Here, this is a homogeneous equation where m is equal to x square y minus 2xy square and n is equal to minus x cube plus 3x square y. This is homogeneous because m is of degree 3 and n is also of degree 3. Each term in m, that is x square y, here degree of x is 2, degree of y is 1, therefore 2 plus 1 is 3. And in the second term, degree of x is 1, degree of y is 2, so 1 plus 2 is 3. So degree of m is equal to 3. Similarly, degree of n. So here it is x cubed, so this term is of degree 3. And the second term x square y, degree of x is 2 and degree of y is 1, therefore 2 plus 1 is 3, therefore n is also of degree 3. Both m and n are of same degree, therefore the given differential equation is homogeneous. Now let us consider mx plus ny. So that is m into x plus n into y. Substitute for m, that is x square y minus 2x y square into x plus n, that is minus x cube plus 3x square y into y. So let us simplify this. So we get, when we multiply by x, we get x cube y minus 2x square y square. And from the second term, we get minus x cube y plus 3x square y square. So here we have plus x cube y. Here we have minus x cube y. Both get cancelled. And here we have 3x square y square. And here minus 2x square y square, which gives us x square y square. Therefore, mx plus ny is equal to x square y square is not equal to 0. Therefore, 1 over mx plus ny is equal to 1 over x square y square is an integrating factor. So we have an integrating factor. Now multiply the given differential equation by 1 over x square y square. So we get 1 over x square y square into x square y minus 2x y square into dx minus 1 over x square y square into x cube minus 3x square y into dy equal to 0. And this is an exact differential equation. So this becomes exact because we have multiplied by the integrating factor. So let us simplify this. So when we multiply the terms here, we get 1 over y minus 2 by x into dx minus of x by y square minus 3 by y into dy equal to 0. So this is an exact differential equation, and we know that how to solve an exact differential equation, and the solution is given by integral 1 over y minus 2 by x into dx, that is this coefficient of dx, which we call that as m. So m dx, keeping y constant, plus integral of all those terms which are independent of x, wherein the first term here in the coefficient of dy is containing x, therefore we neglect this term. But the second term, that is minus of minus 3 by y, which gives us 3 by y, is independent of x. So we consider the term 3 by y, which is independent of x, into dy equal to c. Now we need to integrate this and obtain the solution. Here y is constant, therefore 1 over y is kept constant, and we have 1 into dx, so which gives us x. So 1 by y into x. Here minus, so minus 2 you retain as it is. 1 by x dx gives us log x. Plus, here 3 is a constant, retain that as it is. 1 by y dy gives us log y, and that is equal to c, the constant of integration. So let us combine both the log terms. So from here we get as log of x to the power of minus 2, and here we get log of y cube. So combining these two, we get log of y cube by x square, and here you get x by y, and that is equal to c, and this is the solution to the given differential equation. Next, let us consider one more example. X square y into dx minus x cube plus y cube into dy equal to 0. So this is the given differential equation, and this is homogeneous, where m is x square y and n is minus x cube minus y cube. This is homogeneous because degree of m is 3 and degree of n is also 3 because you have x cube, y cube. So degree is 3. Here you have x square into y. So 2 plus 1 gives us 3. Therefore, degree of m is also equal to 3. Since degree of m and n are equal to 3, the given differential equation is homogeneous. Now let us consider mx plus ny. So we get x square y into x plus minus x cube minus y cube into y. So multiply the terms, we get x cube y minus x cube y minus x power 4. Here x cube y minus x cube y gets cancelled and we get minus x to the power of minus y to the power of 4, and this is not equal to 0. Since it is not equal to 0, we get 1 over mx plus ny, which is equal to 1 over minus y to the power of 4 as an integrating factor. So you take this integrating factor and multiply the given differential equation by it so that the equation becomes an exact differential equation. So let us multiply now. So when we multiply by minus 1 by y to the power of 4, we get minus 1 by y to the power of 4 into x square y dx plus minus of minus becomes plus here. So 1 by y to the power of 4 into x cube plus y cube into dy equal to 0, and this becomes an exact differential equation. Let us simplify this, that is multiply by the terms. So here 1y gets cancelled and we get minus x square by y cube into dx. And when we multiply here each term, so it is x cube by y to the power of 4 plus 1 by y into dy equal to 0. And this is an exact differential equation. Since it is an exact differential equation, the solution to this exact differential equation is given by integral minus x square by y cube, that is the coefficient of dx here, keeping y constant, plus integral of those terms in this which is independent of x. The first term contains x, so we neglect that term. Second term is 1 by y, which is independent of x, so consider 1 by y dy equal to c, where c is the constant of integration. Now let us integrate the terms. So here in the first integral, we need to keep y constant. So minus 1 by y cube, you retain as it is. You integrate x square, we get x cube by 3. Plus 1 by y dy gives us log y, and that is equal to c. And this is the required solution to the given differential equation. Let us discuss one more example. Solve xy dx minus x square plus 2y square dy equal to 0. Once again, this is in the form of m dx plus n dy, where m is xy and n is minus of x square plus 2y square. So consider the differential equation, and this is homogeneous because m is equal to x into y, degree of x is 1, degree of y is 1, so 1 plus 1 gives us degree of m, that is 2. And degree of n, each term is of degree 2, therefore degree of n is also equal to 2, therefore both m and n are of degree 2, therefore the given differential equation is a homogeneous differential equation. Now let us check whether mx plus ny is equal to 0 or not. So let us consider m into x plus n into y. So let us multiply the terms here. We get x square y minus x square y minus 2y cube. So x square y gets cancelled and we get minus 2y cube, and this is not equal to 0. Therefore, we have the integrating factor 1 over mx plus ny, that is equal to 1 over minus 2y cube, and this is the integrating factor. Now let us multiply the given differential equation by the integrating factor 1 over minus 2y cube to get minus 1 over 2y cube into xy dx minus of minus, now it becomes plus 1 over 2y cube into x square plus 2y square dy equal to 0. Since we have multiplied by the integrating factor, this equation becomes exact. Let us simplify the terms here and we get minus x by 2 y square dx because one of y gets cancelled here. And now let us multiply by 1 over minus 2y cube between these two terms. So we get x square by 2y cube plus 1 by y into dy equal to 0. And this is an exact differential equation and the solution is given by integral m dx. Here m is minus x by 2 y square into dx keeping y constant and plus integral of the terms wherein they are independent of x. First term contains x here, so neglect this. Take the second term, that is 1 by y, which is independent of x. So 1 by y dy equal to c, where c is the constant of integration. Now let us integrate the terms. In the first integral, we need to keep y constant. So minus 1 over 2 y square you retain as it is. You integrate x, that gives us x square by 2. So we get minus 1 over 2 y square. You retain that as it is. You integrate x, we get x square by 2 plus integral of 1 over y dy gives us log y, and that is equal to c. And when we multiply this 2 into 2 in the denominator, we get 4. So we get minus x square by 4 y square plus log y equal to c. And this is the required solution to the given differential equation. Thank you.